Lesson 7.1, Monomials and Factoring. So now we're going to take a look at going the other direction compared to when we were expanding. Now we're going to factor. Now to do this we have to know a couple key terms, and that is to know exactly what is factored form, and meaning what are prime numbers, and then the greatest common factor. Now factored form basically spreads things out. Okay, so if you were considering last chapter when we looked at taking x or 2x squared times 3x to the third, we multiplied those, we got 6x to the fifth. Alright, this would be the opposite of factoring. So we are going to now go this direction. Okay, so prime numbers, make sure we understand what prime numbers are. That's when you have factors of the number itself and 1. So a prime number would be considered 2. 4 is not prime because 2 can go into it as well as 1 and 4. 5 would be prime. 6 is not prime because it can be divided by 2 or 3. 7, 10, 9, no, 8, no, 10, no, 11 would be the next one, etc. Those are prime numbers. Greatest common factor, the product of the prime factors common to 2 or more integers, and we'll get to that in a moment. So let's go the other way. Now, where in our last unit this would be considered finished, now we're going to break that apart and find out what are the prime factors. Okay, so first of all, the variables are easy. We're going to write y times y. We're not going to write y squared. We're trying to factor it out now. There's x to the third, which means there's 3 of them. And now we just have to break down 25. Well, factors of 25 are 5 times 5, and both of those are prime. So we would put 5, 5, and you can make that, and we'll just bring out the negative 1 as well. You could have the 5 as negative, that'd be fine too. So we have our y's split up into 2 pieces, our x's split up into 3 pieces, and the prime factors of negative 25. And this would be considered finished. Next one, we'll start again with the variables. That's easiest. So a times b, that's the same as a squared b. And there's a couple different ways to find prime factors. A lot of people like to do divided by 2, and that would give you 18. 2 times 18, divide that by 2, and you get 2 and 9. 9 can be divided by 3 and 3. And here you have the prime factors. So we would write then 2 times 2 times 3 times 3 times a times a times b. And that is considered factored. Next question, same idea. Let's take a look at this one first. So we have 2 and 17, I believe. 17 is prime, so our answer is 2 times 17 times, now there's 3 y's and 4 z's, and that is considered factored. Next one, 2 goes into that 26 times. There's a negative in there as well. 26 is 2 and 13, and 13 is prime. So negative 1 times 2 times 2 times 13 times c times d times d. Okay, greatest common factor of a set of monomials. Now again, greatest common factor is the largest number that goes into both numbers. Now it can be one of the 2 numbers or smaller, but it cannot be bigger. That would be multiple, greatest common multiple, or least common multiple. So greatest common factor is what factor goes into 21 and 49, and it has to be the biggest ones. So there's a couple ways to do this. One is to say, well, I'm going to find out the factors of 21, and that's 3 times 7. Find out the factors of 79, and that's 7 and 7. So what's the biggest number that goes into both? 7. So the greatest common factor for those numbers would be 7. Next one, 12 and 18, so let's find that out. So if I do the same process and find prime factors for 12, we get 2 and 6, 2 and 3. 18 is 2 and 9, and 3 and 3. I'm going to draw this up a little bit differently than I did to start here to make it look a little bit more clear. The first one I'm going to write as 2 times 2 times 3, and then I'm going to put the letters A, B, and C. Then below that I'll write the other one, which is 2 times 3 times 3 times A, and then B, and B. Now what we're going to look for is what they have in common. Okay? Now they both have a 2. Okay? They both have a 3 at most. Now this one, the first one has 2 A's, and then the bottom one only has 1, so in common they have 1 A. B's, they both have at least 2, or at most 2. And they do not both have a C. So the greatest common factor would be what they have in common. They both have a 2, they both have a 3, they both have 1 A in common, and they both have 2 B's in common. So our greatest common factor would be 6A B squared. Greatest common factor. Next one, let's write that out the same way. We'll go 6 is 2 times 3, and then Y, and then 4 Z's. Then 18 would be 2 times 9, we found this out to be already 2 times 3 times 3, then an X and a Y. So what do they have in common? They both have a 2, they both have 1, 3, neither of them have they both don't have an X, they both do have a Y, and they both do not have Z's. So our greatest common factor would be 2, a 3, and a Y, or 6Y. Next one, I want to find this one out first. 2 times 20, 2 and 10, 2 and 5, 2 and 25, 5 and 5. So let's write those out. 2, 2, 2, 5, A, B, C, and a C. That's the first one. The next one is 2, 5, 5, 5 A's, 3 B's, and a C. What do they have in common? Well, they both have 1, 2. That's right here. They both have a 5. They both have 1 A, 1 B, and 1 C. So 1 B and 1 C. So 10 A, B, C. Alright, make sure I got that all done. I want to add one example in here because it has 3 and I think it's worth mentioning. If we take a look at each one, we found out this one has prime factors of 2 times 9 and 3 and 3. So this one's going to be 2 times 3 times 3 and then X. This one has 2 and 15, 3 and 5. So this one's going to be 2 times 3 times 5, XX and Y. And then this one has 2 and 27, 3 and 9, 3, and 3. So it's going to be 2 times 3 times 3 times 3 times x times y. So what do they have in common? They have 1, 2. They all have at least 1, 3, or at most 1, 3. And that's it. There's your 2. There's your 3. And then they all don't have anything else besides an x. And again, they don't all have a y. So 6x would be considered the greatest common factor. And this ends lesson 7.1.